Hello everyone. This is going to be an extensive porting video, and not just to show you more in depth the porting that we do, which you guys have probably seen before, but we are actually going to show you a new service that we offer, which is, it's kind of like splitting the process of porting, where our CNC machine is actually going to cut the port shapes. So in this case, this is an RX-8 intake and exhaust template. We are actually going to show you the machine work that we do on our CNC machine that will cut these ports out and modify these ports for a higher flow. Same with the street porting that some people offer, and same with the bridge porting that you can also buy templates for. Now, the other bonus behind this service that we're offering is the customer now has the availability to do a lot of their own porting. Meaning, we take care of the critical areas. We cut out the port shape on the machine, and the customer will do from the runner to that work that we have done. And although we've always offered complete porting, which is still available, we have the addition now of CNC porting from start to finish that you can buy through rotorengine.com, sending us your engine parts or buying an engine through us. But one of the things that this new service avoids, if the customer is interested in doing their own porting, cost of a template, and the concern that somebody might have about not getting their lines right, or slipping, or maybe not doing a great job of closing angles, for example. So we're going to take you over to the machine and actually show you the machine in action, and we'll explain a bit more about what this service does for you and how it benefits the customer. So these are the different examples of ports we're going to do today on the machine. As we talked about earlier in the intro, obviously rotorengine.com has been offering porting services for near 20 years, and all of our mail order customers or in-house customers get complete work done here, where we do start to finish porting. For mail order customers, once they send their irons and rotor housings, any respective pieces to get their port work done, what we're offering now is still the same complete porting, whether it be the street port or the larger extend port or the bridge porting. We are offering start to finish porting, all done in-house by us, but we have a new option now, and that is where we do the CNC work to do the port shape. Don't know if you can see here, but if we zoom down onto the street port, what we'll show you is the standard port is just in the inside perimeter here, and that may or may not be that obvious in the camera, but what you probably can see quite obviously is we've taken the CNC machine and we've done just the preliminary shape of the port, this very outside line, to show you what we will be shaping the port to. Same with the extend port for a more aggressive single turbo application. Even guys who are doing a half bridge would probably do something like this port for the primary. And again, because these are primary ports, there's not a whole lot of material that we are removing. But in this case here, with this this large extend port, this is actually a port that we designed to cover all turbo primary intake ports, and it is literally going as far as you can, top, bottom, and as far as we're comfortable with to the outside edge, leaving enough room to implement the bridge if we want to, without hitting the water jacket, but staying safely within the margins of the casting, where we're not going to poke through or get too thin, but giving the absolute maximum cross-sectional area for the port size on a primary. And this is as big as you can go. So again, the factory port shape is just in here. But what we've scribed to, and what you can see, is this goes all the way much higher on the top, far enough to the outside to still leave room for the bridge if necessary, and quite far down on the bottom. And you'll see this port is actually squared off on the bottom. And the reason we do that is to maximize flow and to take advantage of the casting material that there is available in all turbo plates. This port will cover any turbo plate starting from 87 all the way to 2001. So we're going to start with this street port on the milling machine, and we'll show you how far down we go if a customer wants to do the majority of their own porting, but wants to save the time and possibly skip past what's the most difficult portion of porting, which is shaping these radius in the corners and the radius on the bottom, and most importantly, keeping this closing angle line exactly where it belongs and keeping it straight. So again, when the side seal closes off the port, it's like a pair of scissors. So both of these ports have the closing angle line built into the program. And again, the main reason to offer this new porting option is, first of all, it costs you much less because we don't do any handwork ourselves. We do only work on the machine. And although the machine work is accurate, and therefore you have to pay a certain amount of money to have the machine do what we've programmed it to do, we're taking out the very difficult task of shaping. And this machine work that's just a scribe line more or less right now is going to turn into the proper angle on the way down through both tops of the ports, and also the correct distance from the coolant seal groove to the outside of the port. And we're going to go down about 6 millimeters in total. So when we're done, we will show you the final product as to what you would receive, where now your job is just to port the runners and then blend the runner to the work that we have done, which will be a lot more obvious as to what you need to do once we show you some close-ups of this port finished. So what we're going to do now is we're going to put the street port on the machine first. We'll show you some of the preliminary cutting on the machine. We'll probably fast forward to the last bit of the process, and then we'll take the plate off and show you the close-ups. Same with the large extend port, and later on we're going to move on to doing the secondaries, where we're actually going to cut the bridge port as part of our the ports we offer. And specifically on the bridge porting, that is one of the reasons we designed this option for what you can purchase from us, because anyone who's taken a run at cutting the hole in the bridge port here knows that is the most difficult part of the task. You can make big mistakes easy if you've never done one before, and even if you do successfully complete the bridge, sometimes the bridge takes as long or longer than the entire hand porting of the runner and the port itself, and all the blending, polishing, and finishing work, period. So cutting the bridge where the hole pokes right through to where the customer does not have to do anything with that bridge port is a big bonus. But again, we'll emphasize more on that once we take you to the secondary porting. So let's move on with the primary, and we'll see you in a minute. Okay, so that street port is finished, and what we will do now is we will dismount this iron from the machine and give you some close-ups of what we got. Okay, so this is the final product for the street port. Perfect straight line, beautiful radius in the corner, radius on the bottom, equal distance from the cool and seal groove to the outside of the port. And you can see all this shiny area in here that I'm marking with red ink. That's what's been removed from the upper side of the port. And the nice part about that is deep in the corner here, you'll find that we've got a beautiful transition that sort of follows this line. So when the air comes in, it wants to blend right into the direction of the flow. If I tilt this up a little bit, you might be able to see the inside and the bottom a bit better. So hopefully you can see that now. And what that shows you again is it's actually the machine has taken out material along this inside edge here as well to sort of help shape that with the runner. And then it's taken out a bunch of material on the bottom here, which is again a very nice transition from the inlet to go into the intake area. And so if I put my pen through here, you can see that the work that one will have to do is the same work we do here, where we start blending this area and all this line along here and then along the bottom here into the port shape the machine has done for us, and then slowly bring that back and start doing the inlet of the runner itself. And if you take your time and you're careful and you have good quality die grind tools, which we may be offering soon or might be on our website already, ones that we've proven to work well for the average die grinder, you'll end up with the same product or close to that rotorengine.com has been offering for 20 years. Again, this being the hard part, it's done for you, but you can still have a lot of fun practicing on porting without worrying about making critical mistakes. Because if you slip in here, the worst that can happen is you have a little scratch that you now have to polish out. But if you slip up here, that's when the damage can occur. So this will probably save you about 60% of what we would charge to do this entire port just by having this preliminary shaping done. Okay, so now we're going to move on to the large extend port, which is the same port we use for full bridge primary and secondary bridge motors. And we'll show you again the preliminary cuts and the final cuts on that, and then we'll get back to where we are with this one in a minute. Right about now. Okay, so that's done. Before we show you some close-ups of what kind of work the machine's done, we're actually going to run another quick program here, which we do on the primary port. And this is for guys who want to do either a full bridge motor from scratch, or we can run the bridge hole independently of the main port. or we can run all at once. But it's also for people who already have done their own primary port, or who have bought a car, taken apart an engine, notice that the primary port is already done, and pending that they have enough room and they haven't taken this port too far back, we can just implement the bridge for the customer. So what we're going to do real quick again before we dismount this piece is we're going to run just the bridge program and cut the hole, and then we'll show you the entire port all at once when we're done. See you in a minute. Okay, so that was the hardest part of this entire task. Again, made much easier for somebody who wants to either install a bridge on top of their already ported primary port or secondary port, or do a bridge port in full. Again, you'll get all the preliminary work on the upper port and the bottom here and so on, like we showed you, and the bridge itself. And when we show you the secondary bridge port, which we will carry on after this, we will not just do the secondary port and the bridge all in one process. We're actually going to show you guys the machining the notch in the rotor housing to match this bridge port, which is kind of cool. And then we'll stack the pieces and show you everything assembled. So stand by and we'll dismount this piece from the machine and we'll show you close-ups of what we have. Okay, so we've dismounted so you can see this a little better. Again, I'm gonna mark off the areas that the machine did for us, or for you, for anyone who wants to try this. So that entire area here has been shaped and sloped, straight line closing angle. It's been modified here on the inside, and then on the bottom, hopefully you can see this okay, it's been heavily modified down here, whereas the street port is much further up this way and isn't so deep and has more of sort of a radius on the bottom. And again, this is to maximize on the port flow. Great for Bridgeport motors or for single turbo motors. Now you can see here, I'm not sure if you can see my pen on the other side, but this hole for the Bridgeport is entirely through and is finished. There is nothing to do here. Anyone who gets just the bridge or the combination primary bridge or the secondary bridge, this port is done. Okay, so we will go ahead and do the entire runner inside and all the blending here for people who want to do primary street, extend street, or extend street with bridge, and we will do the runner and all the blending. And again, those of you who want to do your own work, sort of from those marked areas down and into the runner, there's nothing to do in here. Okay, so we're going to move on now and show you the scribed mark for the secondary port, and we're going to run the program combination secondary port with bridge. See you soon. Okay, so now we've moved on to do our secondary ports. What we've done, again, like we did the primaries, is we've actually taken a preliminary cut, which is a scribe mark, to show you guys what exactly is going to be removed from the turbo bridge port. So the obvious is this bridge here, okay? Then this whole top area above the port and extending the port down to the bottom here. You may not be able to see that real well, but there's quite a bit of extra material coming out from the bottom. And then there's some material along the outside edge, again designed to keep the distance from the coolant seal groove to the edge of the port the same all the way across, and leaving ample material between the outside edge of the bridge and the coolant seal wall. As we explained earlier during our introduction, one of the benefits to doing this sort of new service where we do the top portion of the port for you and the shaping of the port and so on, beyond the simplicity and the accuracy that you'll get from this, this is the same exact cutout that we use from the template that we sell, which is the Extreme Rotaries template. And this is a $100 template. So the way we look at it is not only does the customer get to do their own porting inside the runner and blending and practice, and for the most part can say they ported their own engine, but you don't have to buy a template anymore because the work is done. So we're going to go ahead and mount this to the machine and show you guys a little bit of the machine cutting this extra material out. And we'll do a start to finish, but there'll be a break in the middle, so we don't have to bore you with machine work. And then we'll show you the final product as to what you would get if you sent us any secondary, meaning front or rear irons for turbo extend port or combination bridge port work, and what it would look like when you receive the irons before any work is done in the runners. Okay, so see you in a minute. So what you'll notice right now is, because we've already done that initial scribing on the plate and we've removed that material, you won't hear the machine cutting anything for about the first minute or so, because we've already done those. So right now it's like it's cutting dry, or cutting what we call in the air. And as soon as you start to see shavings expelled and you hear some grinding noise, we're back on porting. Okay, so program is finished, and that is final product. You can probably see we've gone down quite a bit further at the top of the port. The bridge is entirely done. Should be able to see my pen underneath here. And this bottom area in here is stepped down at least 9 to 10 millimeters. And that's a real critical area there too, because when a lot of people port, when this material is not machined out and it's sort of parallel with the bottom of the port, which runs in about there, people have no idea how much more flow you can obtain out of this port when you bring this down and bring the bottom of the runner parallel to the bottom of the new port. And when you blend that in, there's a ton of material back in here that you can attribute to easily another 10% in overall volume that will go through this port. Okay, so once the customer is ready to blend, this transition and angle here is very, very simple to clean up and to blend in. And the bottom takes a little bit more effort, but the purpose of this whole concept of us cutting this preliminary work for you again is equal spacing, perfect closing angle on the roof of the port, perfect spacing and size on the bridge. Spacing meaning distance from the port to the bridge all the way across and to the water jacket all the way across. And then keeping this distance parallel, and the shape of the port is going to match 100% with the back rotor, and in the case of a 20B, the center rotor. Okay, so now what we're going to do is we're going to cut the notch in the rotor housing for the bridge port. And this is not a real big notch or cutout. This is just enough so when the housing sits down on top of the end housing, the edge of the rotor housing isn't blocking the port. It's actually working in conjunction with the size of the bridge port above the regular port. And this is obviously to obtain maximum flow. So we're almost done. Should be a couple more passes here just to smooth and polish it out. The machine's programmed to sort of do a final pass to clean up the rough edges so there's no burrs on the chrome. And this port actually literally is good the way it is when it's finished, because there's nothing really to do. We might take some Scotch-Brite and polish it, but that's literally all we have to do. Again, one more final little bit of a skim here. And the machine is done. So now we'll show you what we get for a finish here. I'm not sure if we can zoom in on this, but you can see that this is taken down about 6 or 7 millimeters. And you probably can't see it in the camera, but there's actually a concave pocket sort of built into the back side of this notch. And then the edge here, we will show you in a minute, when we match this up with the end housing, you'll see how tightly this fits to the matching bridge port on the main port. Okay, so we'll see you in a second. Okay, so we've shown you the full bridge port on the secondary, and now we are going to take the rotor housing that we just notched to line up with our bridge port and show you how that goes together. So the final product is here. You can see that, and that is designed, when you put your dowel pins in, you'll see there is a perfect alignment here between the bridge port and the notch. I'm not sure if you can see my pen underneath there, but the point is that we've got optimum flow notching this rotor housing, and that is what you need to do to make this bridge port flow functionally.